Okay, had a chance to try these? Nice thing about this is that for the first two sections and underneath the try this heading, I'm not actually asking for you to give me answers. I just want you to write them in the form other than the one I give you. For instance, the first ones I give you are in exponential form. All I want you to do is practice writing them in expanded form. You don't have to sit there and calculate them. I'm not going to say you can't. I mean, sure, go ahead, but you don't have to. Basically, I just want to make sure that we're solid on what this number is telling us to do with this number. What is the power telling us to do with the base? Okay, here we go. Here I have a base of 5. I have a power of 3. So how many times am I going to list this base? 3, right? 1, 2, 3. This is repeated multiplication, so in between each one of these goes a multiplication sign. There you go. Next one, 7 to the 7th power. This is the base, that's the power. 1, 2, 3, 4, 5, 6, 7. It's a lot of 7s. And again, this is repeated multiplication, so make sure you're putting the multiplication signs inside. Are you curious? You want to see what that is? I'll save some time by putting into the calculator. 7 to the 7th power, whoa, is, ready? 823,543. See how fast those numbers get big? Okay, we only multiplied it 7 times, and it's already up to almost to 1 million. Okay, so exponential form or exponential growth happens pretty fast. How about 11 to the 5th power? 11 is our base, right? And this power is telling us to write that base 5 times. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Multiplication symbol in between each one because it's just repeated multiplication. Are you curious about that one? It's a bigger number, a bigger base. I'm wondering if it'll be bigger than this number. Let's find out. It is. It's a lot bigger. Let me see. This calculator is actually going to give it to me in a really big, it says 2.85. I'm going to go ahead and round this to 2.9. We haven't gotten into scientific notation yet, and that's actually not until a 7th grade skill. But basically my calculator spits out the number 2.9 times 10 to the 11th power. Now this is called scientific notation, and don't let me distract you too much, but basically this means 2.9 with 11 zeros after it, okay? And that's a lot. So it's a lot bigger than this number, okay? Don't worry too much about that though. If this is like distracting you, then just don't worry about it, because the whole point of this exercise is to make sure that you're okay with writing this in expanded form. Now here's a variable. Remember we did the y's in the lesson? Here we have x's, and the x, it's still the base. The rules are still the same, and the power tells us how many times to write it. Okay? And again, this is repeated multiplication, so this is us multiplying x 4 times. Good? Now, the next section gives you a whole bunch of expanded exponents and wants you to put it in exponential form. So the first one, I'm not going to write it on here because you have it in front of you, but the first one, a, says 2 times 2 times 2 times 2 times 2. It's got 2 written 5 times, right? So the base is 2, and then the exponent is the number of times that 2 is being represented in that expanded form. So I counted 5 2s, that's the exponent. Easy enough, right? The next one is 12 times 12 times 12. Okay, easy enough. 12 is the base. That's the power. See how easy that is? Take the base, count how many times it's being represented, and write that number in the powers place. The next one is a bunch of y's. It says y times 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 y. Did I count that right? 1, 2, 3, 4, 5, 6, 7, 8. Okay? So the base is y, and it's represented 8 times. Piece of cake. And then the last one, I guess that's just here you go, I'll give you an easy one because you're almost done. 4 times 4, the base is 4, and I only counted 2 of them. So 4 to the second power. Doing okay? All right. But think about this, isn't too hard, but it does give us the number 64. And it wants us to write that in exponential form in at least 2 different ways. So we're gonna have to think of what do we multiply by itself to get 64. And we're gonna have to think of that in 2 different ways. I can think of one way that we can multiply a number by itself to get 64. Can you think of the number that I would have to multiply by itself to get 64? I come up with 8. Isn't 8 times 8 64? Okay, and what I just wrote here is actually expanded form. It's expanded multiplication here. So can't I just write 8 as the base? And it's being represented twice, so I can write that as a power. Right? So that's one way. 8 to the second power is 64. How else? Can I use 4? Interesting. What happens when I divide 64 by 4? Well, 4 goes into 6 once. 4 goes into 24, and I get 16. And isn't 16 just 4 times 4? Okay. So couldn't I multiply 4 times 4 times 4? Does that give me 64? Yeah, it sure does. Success, okay? So here I have a new base that's being represented 3 times. So 4 is the base, and it's being written 3 times. So another way to write 64 in exponential form is 4 to the third power. These both actually give me the same answer. Okay? I can think of one more way. Ready? Let's see if you thought of this one. 2 times 2 times 2 times 2 times 2 times 2. And I'm done. 1, 2, 3, 4, 5, 6. Does that equal 64? Well, there's 2 times 2, that's 4. 4 times 2 is 8. 8 times 16 times 2 is 32. And 32 times 2 is 64. So I have a new base, and the power tells me how many times it's represented. 1, 2, 3, 4, 5, 6. So there's another way you could do it. Now I think that might be it. If you think of another way, go ahead and leave it in the comments maybe, but I think that's it. So I have 3 different ways that I could have written in exponential form to show 64. Okay? I'm hoping that you came up with at least 2 of those. Okay. Last part is the problem solving. I'm going to scroll down a bit so I can see all 3 of them. There we go. The first one says there are 10 to the 6th millimeters in a kilometer, or a kilometer. Write the number of millimeters in a kilometer. Okay. I know that there are 10 to the 6th meters in a kilometer. How many is that? What's that number? Well, let's first write it in expanded form, okay? This says 10 times 10 times 10. That's 3 so far. 4 5, 6. 1, 2, 3, 4, 5, 6. Cool. Now it's in expanded form. Now I can just multiply from left to right. 10 times 10 is 100. Right? I always think it's a good idea to write the whole line again for every change you make. The only change I made so far was those two, and there it is. And then rewrite everything else. Yes, it might take up some space on your paper, but get used to it, because when we get into algebra, you're gonna have problems that take up maybe even a whole page. So it's okay. Much more important to stay organized than to try to save space, okay? 100 times 10, just add a 0, right? That's the magic of tens. So those two together give me 1,000, and I'm gonna rewrite the 3 that I haven't touched yet. Okay? Oh, this is millimeters, I'm sorry. I'm sure you already knew that, but I just wanted to make sure I'm correct. Okay, 1,000 times 10, just add another 0. So this is now 10,000 times 10 times 10. Add another 0. And then bring down the 10 we haven't touched yet. And then add one more 0. So in 1 kilometer, which is pretty big, it's a little over half a mile, there are 1 million millimeters. Okay? And that pretty much makes sense, because there are 1,000 millimeters in a meter, and there are 1,000 meters in a kilometer. I know that. So 1,000 times 1,000 is 1 million. Okay? Try to, whenever you're matched with a 10 to the something power, go ahead and practice this. Add a 0 every time you multiply a 10. Try not to whip out your calculator yet. This is good practice for stuff. Okay? All right, next one. Says the African elephant is the largest land animal and weighs about 8 tons. Write this in exponential form. So this is kind of like that 64 we had. We have 8 tons. At an exponential form. Well, I have to think about what do I multiply together to get 8. And it has to be the same number. So in other words, I have to pick a number that I can multiply by itself at least once, okay? I can't multiply 4 times 4 because that gives me 16, that's too big. 3 times 3 is 9, still too big. 2 times 2 is 4. Okay, so let's start with that. 2 times 2 is 4, right? Can I write another 2 right here and make that 8? 2 times 2 is 4, 4 times 2 is 8, voila. Okay, and if I wanted to show this in exponential form, because that's what they're asking for, I have the base 2 represented 3 times. So the African elephant is 2 to the 3rd power tons, or 2 to the 3rd tons, okay? Not too bad. And the last one. The school library contains 9 to the 4th books. I'm gonna write that down. How many library books are in the library? So they want us to, again, actually calculate this. So whenever you're gonna calculate out an exponent like this, go ahead and start by writing it in expanded form. The base is 9, represented 4 times. Here's my 4 9s. And of course I'm multiplying each one, right? So let's start from here. 9 times 9 is 81. And then bring down the 2 9s that I haven't touched yet. Okay. I didn't put the little calculator icon next to here, so that means you shouldn't really use calculators. We don't need to. If you can't do 81 times 9 in your head, and who really wants to, go ahead and off to the side, use your algorithm. Okay? It's good practice. 1 times 9 is 9. 8 times 9 is 72. So 729 up to here. And then bring down this last 9 that we haven't touched yet. And then we'll do the algorithm one more time. 9 times 9 is 81. carry that 8. 9 times 2 is 18, plus that 8 is 26. And then 9 times 7 is 63, plus that 2 is 65. Whee! So this school library has 6,561 books. That sounds like a lot. The school library contains that many books. That's about right for a school library. Okay? Nice selection of reading material. If you feel like you need a little more practice going from exponential to expanded form and calculating these exponents, then click the link underneath this video and you can practice until you're comfortable. And when you are, and make sure you are, meet me in the next lesson for order of operations, where we will be using these as well as all 4 other operations, and we're going to be bringing in some stuff inside the parentheses. Very important lesson next time. Can't wait to get to it. And then we're going to dive kind of into algebra. All right, I'll see you there.